The one the electric power dissipated in the resistor completely unchanged. So, before we look at the choices, we can quickly list out our variables first. So we have P, which means power, which is the power, and it's measured in watts. We have V, which is voltage, um, and it's measured in volts. And we have I, which is the current, which is measured in amps. And then next we have R, which is the resistance, and it's measured in ohms. So to solve this, we need to use three different equations for the electric power. So depending on what information like the problem gives us, we can use either P equals the current times the voltage, so P equals IV, or P equals the current squared times the resistance, so P equals I squared R. Or we could use P equals the voltage squared over the resistance, so P equals V squared over R. So can test out each option one by one to see like what happens to each one. Best option is to use the first formula we wrote over here, P equals IV. So if we plug in our charges, our new voltage would be 2V and our current is 1/2 I. So P, our new power would be 2V times 1/2 I. And if we multiply those together, the 2 and the 1/2 will just cancel each other out completely, which would leave us back to IV. And since IV is just our original power, the power doesn't change at all. So option A is correct. Um, Now for option B says we double the voltage and we increase the resistance by a factor of 4. And use our third equation, P equals the voltage squared. So it would be P, okay, let's just P nu equals 2V squared over 4R. And so when you square 2V, you will just get 4v. So let's see. 4 4v squared. So our equation will be 4v squared over 4r. And the 4 on top of the over, and that's exactly what we started with in the original equation. So option B also leaves the power unchanged. And now we can check option C, which tells us that we're doubling the current and reducing the resistance by factor 4. So for currents and resistance, we use P equals I squared times the resistance, which is exactly our second equation. So if we plug in our numbers again, it will be P mu, and plugging in our numbers, it would be 2I squared times 1/4. Our resistance becomes 1/4 R. And so squaring 2I will give us 4I squared times 1/4 R. And so the 4 and the 1/4 cancel each other out to equal 1, which just leaves us with I squared P mu, which will just leave us with 1 squared I squared R, and that matches our original power equation too. So because each single one of these cancel each other out, mathematically that leaves the power exactly the same. So that means all three of these don't make a change. So the correct choice is A, B, and C. Because so thank you for watching.